So this is going to be one of multiple videos. I'm going to be breaking these videos into parts so that you can watch a little, add some notes kind of on your own time. And these are theorems that I want you guys to put into the back of your composition book. So you don't have to do all of these over the weekend, but these are ones eventually I want you guys to get in. So when we do these theorems, I would like for you guys to put them in the back of your composition book. So when I say the back of your composition book, I mean, you're going to flip to the very, very back of your composition book, and we're going to work our way backwards. That way you know where all your theorems are. You're not trying to find them in each chapter, okay? So let me get started. This first one's going to be on ones that are angle relationships. So first one we're going to start with is vertical angles. So vertical angles theorem. And for this one, let me just zoom in a little bit. Vertical angles are congruent. So vertical angles are congruent. And an example of that, if I have intersecting lines, let's say this is angle A, let's say these are B and C. B and C would be considered vertical, and so I would say angle B is congruent to angle C, again, because vertical angles are congruent. The next one, Pythagorean theorem. Okay, so for the Pythagorean theorem, if a triangle is a right triangle, so if a triangle is a right triangle, then leg squared plus leg squared equals hypotenuse squared. Okay, and I'm going to draw a picture of that. So let's say I have this triangle. Let's say this is A, this is B, this is C. These are your legs, this is your hypotenuse. So we have A squared plus B squared equal C squared. The next ones are going to be dealing with parallel lines cut by a transversal. I'm going to start with corresponding angles. So corresponding angles. And I'm going to write two of these. One of them is going to be talking about if the lines are parallel cut by a transversal, then the corresponding angles are congruent, and the other one's going to be the converse. Okay, so corresponding angles. So let me move this up. Okay, so if a pair of parallel lines are cut by a transversal, if a pair of parallel lines are cut by a transversal, then corresponding angles are congruent. And a picture of that. So here's my parallel lines cut by my transversal. And let's say we'd have angle A, okay? And this is angle B. These are corresponding angles. And we would say angle A is congruent to angle B. Now the converse is also true. So that is if corresponding angles are congruent, then the two lines cut by a transversal, okay, then the two lines cut by a transversal that form them are parallel. So again, if corresponding angles are congruent, then the two lines cut by a transversal that form them are parallel. Next one I'm going to do is alternate interior angles. And again, we're going to have two of them. So alternate interior angles. Okay, so again, if a pair of parallel lines are cut by a transversal, then alternate interior angles are congruent. So a picture of that again, parallel lines. Oops, and I didn't put my parallel symbol on the one above. Okay, so draw those arrows so you know that they are parallel. So here's my parallel lines cut by the transversal alternate interior angles. So let's say here's angle A and here's angle B. Okay, again, here's angle A, here's angle B. Angle A is congruent to angle B. The converse is true. So if alternate interior angles are congruent, so if alternate interior angles are congruent, then the two lines cut by a transversal so the two lines cut by a transversal that form them are parallel. Okay, the next one that I'm going to be doing is going to be same side interior angles. So same side interior angles. Okay, so if parallel lines cut by a transversal, so if a pair of parallel lines are cut by a transversal, then same side interior angles are supplementary. So a picture of that, again, parallel lines. Cut by a transversal. Let's say that this angle A, this angle B, measure of angle A plus measure of angle B is equal to 180 degrees. Okay, same side interior angles. We also have the converse. So if same side interior angles are supplementary, then the two lines cut by a transversal So then the two lines cut by a transversal that form them are parallel. Okay, the next one is going to be triangle angle sum. Okay. So triangle angle sum theorem. And the way I shorten that in terms of writing it out, I will write the following. I will write triangle angle sum. So that's my shorthand for it. And so the sum of the interior angles, the sum of the measures of the interior angles, the sum of the measures of the interior angles in the triangle is 180 degrees. Okay, and I'm going to draw a picture of that. So let's say I've got a triangle and I've got this angle A, angle B, angle C. Then the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. Okay. Next one is the triangle inequality theorem. And I'm going to write it in two ways. I'm going to write the theorem, and then I'm going to write if we're trying to find an interval given two sides. So, triangle inequality theorem. Okay. So for the theorem, I'm going to write this: the sum of the lengths of any two sides of a triangle. So the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, so let me draw a picture of that. So let's say this is my triangle here, and let's say that this side is A, this side is B, this side is C. So whatever two I'm talking about, if I'm talking about A and C, then A plus C has to be greater than the side B, or B and C has to be greater than side A, or A and B have to be greater than side C. So if I add up two sides, they have to be a bigger amount than the third side. Now, if you have an interval that you need to be finding, I'm going to write it out in this form. So also, if you have, two sides, so if A and B are two sides of a triangle, the third side C must be in between the difference of the other two sides and the sum of the other two sides. So the sum and difference of the other two sides. So basically, again, if I know A and B and I'm trying to find C, I am going to subtract A and B. Now I'm writing absolute value of A minus B because I want whatever the positive of this is. So the absolute value of A minus B will be less than C, which is less than the sum of A and B. Okay. Now the next one and last one for this video is talking about longest side, largest angle. So that's going to be the next one I'm going to write. So longest side, largest angle. So for this one, if two sides of a triangle are not congruent, so if two sides of a triangle are not congruent, then the larger angle is opposite the longer side. And the converse is going to be true. Okay, so if two angles in a triangle are not congruent, then the longer side is opposite the largest angle. So then the longer side is opposite the larger angle. Okay, I'm going to draw a picture of that. So let's say that this side is A, this side is B, this side is C. And let's say that this one is 80 degrees, this one is 40 degrees, and this one is 60 degrees. Okay, so what has to be true is that this C is going to be the longest side because it's across from the biggest angle, and this B is going to be the one in the middle because it's across from the angle that's the middle size, and then this A is across from the 40, which is the smallest one. So I would say that A is less than B is less than C in terms of their lengths. Again, the longest angle, longest side is across from the largest angle. The smallest side is across from the smallest angle, and vice versa. So that's it for this one. The next video is going to be on triangle congruencies.